Like you don't care where it came from?
No.
How we actually derive it?
No.
Yes, you do care, alright? Okay? So what do you think the derivative of cosine is going to be? Sine?
No, it's not.
That just seems too obvious, right? Like it just seems too obvious. Why would they do that, right? I don't know. Let's try it. Let's derive it, okay? So use the definition of derivative. Old faithful.
Watch this will be like 10.
So we want the limit as h goes to 0 of what?
Tangent is square root of 25. It's either sine x or that.
Cosine of x plus h minus cosine of x over h. So again, we get stuck. The only way to continue is to know the formula for this to expand it, which is up there, right? So what are we going to end up with? Cosine of what? Cosine of x, cosine of h, right? Now this one's the one that has to have a what? No? A minus, right? Because it had a plus. So this will be sine of x and sine of h. All over h. Did we forget something? We forgot minus cosine of x, and we forgot what in the front? The limit as h goes to 0. We ran out of space there. How do you want to attack this one?
Run away. Not virtually do the same thing.
Move the cosine of x like I did on the other one?
Yeah.
Why? That would get those two cosines x together? Alright, let's do that. So we have the limit as h goes to 0 of cosine of x, cosine of h, minus cosine of x, minus sine of x, sine of h, all over h. Okay. And you said to take out a cosine, right? So cosine of x times cosine of h minus 1 minus sine of x sine of h. All over h. Okay? Now what can we do? Take out a negative so we can get it into that form. And I'm going to take out the negative and I'm going to split the fractions, okay? Alright?
Yeah.
So that'll become 1 minus cosine of h, right? Minus, whoops, all of that over h, right? Minus sine of x, sine of h, also over h. We want the limit as h goes to 0. So now we would be putting the 0 in for the h's, but we know that this particular limit as we approach 0 is what? That's 0, right? Times what? Negative cosine of x. Minus, what's this one over here? Sine of h over h. 1. So that'll be sine of x times 1. So that gives us 0 minus what? Sine of x. So what does that end up becoming? Negative sine of x.
I told you that it was going to be negative, right? Yeah, she did say that.
You told her it was
I
going to
was
be
like,
negative?
what's the negative sign?
Wow. But I'm a positive sign. So, what did we discover that the derivative of cosine was? Negative sine of x. So now from this point on you can memorize that, okay? So the derivative of sine is? Cosine. The derivative of cosine is? Negative sine, okay? Later on when we talk about all the other trig functions like secant, cosecant, tangent, cotangent, you're going to discover that every single time we get the derivative of something that starts with a what? With a c, the answer will have a what? A negative in it at the beginning. Okay, just something to help you remember for the future. We can't do those other ones yet because we don't know other rules that we need. For example, tangent. What do you know? Tangent is what over what? Sine over cosine. It's a rational function. Okay, so in order to do that, we need to know the quotient rule. And we haven't learned that rule yet. So when we learn it, we'll throw those in there and we'll learn how to find the derivative of tangent. Cool? Yeah? Alright, so using those skills, let's do these two problems here real quick. Right? And remember that we're going all the way to writing the equation of the line, not just finding the derivative. But let's practice finding that derivative first. Okay? So, if I had this problem and I wanted to find its derivative, actually we're not going to use this problem. Scratch it off. I didn't like it. It ends up giving us an ugly equation of a line, so I came up with a different one. So I'm going to say f of x, not f of theta, because then my thetas get mixed up with my zeros and it looks nasty. Okay, so f of x equals 4 cosine of x minus x. We want it at x equals 0. Well, since I was using zeros and the thetas, I don't want you to get them confused. Good? So, we need to find the point of tangency and the slope of the tangent. Okay, in order to find this one, I need its derivative. So let's practice that since that's what we just learned. Alright, so how would I get the derivative of this guy? What's the derivative of cosine? Negative sine, right? So that's negative sine times 4, we get? Negative 4 sine of x. Well, that was easy. What's the derivative of x?
Negative 1.
So minus 1, right? Alright, we found the derivative. Oh my god, that was hard. Let's take a break.
Down.
3 minutes. Yes.
No. Too easy? Too easy? You can't believe it? Oh, it'll get interesting later, okay? So enjoy it while you can. Alright, so now we're ready to find the equation of the line, right?
Oh, yeah.
So let's do it. So what's my point of tangency? How do I get that? 0 comma something, right? What do I plug it into? Original function. So we want f of 0. So that's 4 cosine of 0 minus 0. Oh no, what's cosine of 0? How could you ask such a thing? What's cosine of 0? Come on! 1 times 4? 4 minus 0? 4. So my point of tangency is 0, 4. Cosine is the what? The what value? X, right? So what's the x value at the 0 coordinate? Right? At the 0 radians, it's 1. That's like an easy one. Second thing, slope of tangent. How do I get that? Plug in the x value into the derivative now, right? So we got negative 4 times sine of 0. Oh no. Minus 1. Why you make it so challenging, sir? What's sine at 0? 1? 0. Okay, sine is the y value, right? So if we think about it, on the unit circle, we're here at 0. This point is 1 comma what? So the x is 1, the y is 0. Right, so this ends up giving us what? Negative 1. Can I write my equation now, Caitlin? Alright, so give it to me, Caitlin. Y minus what? Nope. Y minus 4 equals negative 1 times minus 0. Beautiful, thank you.
I love math.
I love math, excellent. Got it? Try another one? Okay, but we're not going to do this one. Scratch it, please, scratch it. And here's the new one, okay? G of x is equal to 2 plus 3 sine of x at x equals pi. So let's practice getting that derivative. Here we go, Ashley. You watching?
Yes.
Alright, so what's the derivative of 2? Yeah, I'm asking you. The derivative of 2 is 2?
Zero.
0, very good. So that's 0. plus 3 times the derivative of sine. What would the derivative of sine be? Cosine. So this will just give me 3 what? Cosine of it. Super easy? Alright, so now let's get that equation of that line. So we need our point, and it's going to be pi comma something. Let's find it by plugging in that pi. So g of pi, that's 2 plus 3 times sine at pi. Oh no! What's sine at pi?
Wouldn't it be 0?
I don't know.
It's 0.
Zero?
So here it's 0
Okay.
on the left. On the left.
So 0 plus 2? 2. Beautiful. 2 plus 0. How did we get that? Sine of pi of 0, right? Where's pi at?
Left side.
Right here. This point is negative 1, 0, right? What's the y value there? Alright, slope. We want g prime at pi, so that'll be 3 cosine at pi. What would that one give me? Negative 3. Okay, the x is negative 1, so cosine at pi is negative 1 times 3, negative 3. Alright, write the equation. Y minus what? 2 equals? Times?
Pi.
What would be the equation of the normal line? At that point of tangency. Y minus 2 equals 1/3 times x minus 1. Okay? Don't forget, what's the normal line? A line that is perpendicular to the tangent line at what particular point? At the point of tangent. Very good. Okay, so go to your assignment and let's practice a couple more before we do the last part of the notes. So look at 5 and 7. Which one do you want to do? 7? Okay, let's do 7. So before we start, we're going to rewrite this part, right? So that's really theta to the half, right? Plus 2 sine theta. Okay. What would be the derivative of this guy? G prime of theta. The derivative of the first part. No, come on. That's what you did yesterday. 1/2 theta to the negative half plus 2 cosine of theta. Why cosine? Derivative of sine is? Okay, now we just need to rewrite it. Yes? What would it look like? 1 over 2 theta to the half, right? Plus 2 cosine theta. Over what? 1. Oh, we need a common denominator. What is the common denominator going to be? 2 theta to the half, right? So multiply this guy by 2 theta to the half. And multiply this guy by 2 theta to the half. So in my denominator, I have 2 theta to the half. What do I have in my numerator? 1 plus 4 theta to the half times cosine of theta. How come you didn't multiply this theta with the theta of the cosine? Because it's cosine of that theta, right? I can't do anything to that until I take the cosine of it, right? You understand? You have to do parentheses before you multiply, right? I have to do what's in there. I have to find the cosine of that. So that theta actually goes in front. Good? The last step is just to change these to what? Square root of theta, cosine theta. That's why I put the theta in parentheses so I don't get it confused. Even though they don't put it in parentheses up here at the beginning of the problem, okay? Something I recommend. So 2 square root of theta. That was fun.
I'm glad you had that.
It wasn't hard up to this point, right? Would this still be acceptable? Yes, as long as you put 1 over 2 square root of theta, okay? Plus 2 cosine theta. That would still be acceptable. That's okay. Alright, we're going all the way to practice further. Not too bad? No? Alright, one more step, okay? One more thing, the challenge problems. You ready?
Challenge.
These are the problems that will challenge your understanding. Do I really get what's going on or not? Okay? Where am I at? At the very back of the notes. So Daniela, will you read this for us? And then we'll try to break it down, okay?